Plate boundary animations. Objective 1. I can identify the geologic features and events formed at each type of plate boundary, convergent, divergent, and transform fault. Before we can discuss the plate boundaries, we need to discuss what is the plate made of. Well, the plates, as we call them, are made of the lithosphere, and the lithosphere is part of the crust, but also part of the upper mantle. It's a hard, rocky layer, and below the lithospheric plate is the asthenosphere, which actually allows the plates to move because the asthenosphere moves in this circular motion. And so when it's moving this way, it actually moves the plate in the leftward or the westward direction. The asthenosphere over here is actually moving to the right or eastward, and it allows this plate to move right or eastward. The asthenosphere over here is moving to the left in a circular motion, and so it allows that plate to move to the left. And over here, the asthenosphere is moving to the right, which makes this lithospheric plate move to the right. Convergent plate boundaries are where the two lithospheric plates move toward each other or collide. And it's all because the asthenosphere, remember, is moving in that circular motion, forcing those rocky plates that are floating on top to hit each other. And because of that, certain geological features and events are created. The next is the divergent plate boundary, and yet again it has to do with the lithospheric plates, but instead of colliding like with the convergent plate boundaries, the divergent plate boundaries are where the plates divide or separate from each other. And yet again, it's because that asthenosphere is moving in a circular motion, forcing those plates that are floating on top to move, in this case, away from each other. The last plate boundary we're going to talk about is the transform fault plate boundary. Yet again, it's those rocky lithospheric plates, and in this case, they're not moving away from each other, they're not moving toward each other. In this case, they're grinding past each other. Literally, it's kind of like you're sliding your hands when you press really hard, and you try to move one farther forward than the other. All right? In this case, guess what? It's because of that asthenosphere moving in that circular motion that's causing these plates that are floating on top of the asthenosphere made of rock to grind past each other. Now you're going to be taking notes and identifying what are geologic features and what are geologic events. So open your workbook to page 2. All right, so to identify what a geologic feature is, you've got to think, what's a landform? And I know you've gone over that in social studies many, many times. So mountains and mid-ocean ridges. Mid-ocean ridges are mountain ranges, but obviously in the ocean. Volcanoes and islands are types of landforms. Valleys, rifts, and trenches. Valleys, you know what that is. A rift is a valley that occurs at divergent plate boundaries, and a trench is another type of valley that occurs at convergent plate boundaries. And then faults obviously occur at transform fault boundaries, which we'll see later, and then rivers and riverbeds. Geologic events are things we can't really predict. So volcanic eruptions, earthquakes, tsunamis we can predict because they're formed from earthquakes, but we don't get a whole lot of warnings. Avalanches, mudslides, landslides. So right now I would like you to hit pause and copy this into your workbook on page 2. The next part, you're going to need to open up your workbook to page 110, and you're going to take notes on what geologic features and events you can identify from this simulation or animation of the plate boundaries. Like always, be sure to hit pause so you can identify all the geologic features or events, or hit rewind if you need to rewatch any of them. Here you're going to watch an animation or simulation of convergent plate boundaries where the plates are colliding. Be sure to notice the movement of the asthenosphere, how it's moving in a circular motion so that the two lithospheric plates collide. Use your legend to identify what geologic features or events are formed within the lithosphere and even on top of the crust. Click pause at any moment. The next one we're going to look at is when two oceanic plates converge or collide. All right, and this is also needs to be taken in your notes. Notice the asthenosphere here is also moving in a circular motion. And notice what's occurring on the lithospheric plates in within the ocean and the oceanic crust. What geologic features and events are being formed. Please make sure you identify all of them in your workbook. Now this animation is for the divergent plate boundaries. I want you to pay attention yet again to that asthenosphere and the movement that it has on how it moves those lithospheric plates away from each other, or they're diverging from each other. Identify what geologic features and events are formed within the lithosphere and on the crust. All right, click pause at any time that you need to. Use the legend, use this key to help you complete your notes. Last but not least is the transform fault boundary. So I want you yet again to look at how these two lithospheric plates are moving. This lithospheric plate on the right is moving northward, while this lithospheric plate on the left is moving southward. All right, identify the geologic features and events that are forming where these two plates are grinding past each other. Notice there is no space between the two plates. All right, now we're going to look at how transform plate boundaries can also be bent. So notice this curved line between the two lithospheric plates. All right, so the plate on the right is moving northward, while the plate on the left is moving southward. All right, notice along this bend or bent, the geologic features and events that are being formed. All right, be sure to use your key to help you fill out your notes. And look at that, look at those mountains. I wonder how those mountains got so high. And here's one last transform fault boundary that's bent. So notice the plate on the right is moving southward this time, and the plate on the left is moving northward. Notice this gap that's being exposed. All right, notice what's filling it up. I bet we'll have a discussion about that. Use your legend to identify what geologic features and events are being formed by this transform fault boundary. Remember, if you need any assistance with your notes, rewind and rewatch the video, and I cannot wait to talk with you during discussion.